Hello everyone, I'm Comajig and I'll be your tutor for today. Today we'll learn about double angle identities and I'll teach you how to derive these identities and how to use this in solving problems involving these trigonometric identities. So double angle identities are special cases of the sine sum, cosine sum, and tangent sum identities. We call the sine sum identity. If we have angles A and B, the sine of A plus B is given by sine A times cosine B plus cosine A sine B. If we let A be equal to B, so we can write this as sine A plus A is equal to sine A cosine A plus cosine A sine A. Furthermore, you can write this as sine 2A. Simplifying this identity, we have 2 sine A cosine A. And this is the double angle identity for sine. Now for the cosine double angle identity, we make use of the cosine sum. The cosine of A plus B, we know from our previous lessons, that is cosine A cosine B minus sine of A and sine B. Again, if you let A be equal to B, we can have cosine A plus A equal to cosine A cosine B cosine A minus sine A sine A. So simplifying that one, we have cosine 2A. The double angle identity for cosine is cosine squared A minus sine squared A. Furthermore, we can rewrite this identity into other identities from our fundamental identity, sine squared A plus cosine squared A cos 1. We can rewrite, or we can replace cosine squared A here with 1 minus sine squared A. Or we can replace sine squared A here with 1 minus cosine squared A. So cosine 2A can also be written in the form 1 minus sine squared A minus sine squared A, or 1 minus 2 sine squared A. On the other hand, we can also write this as cosine 2A, sine squared A is 1 minus 1 minus cosine squared A from the fundamental identity. You can write cosine 2A as 2 cosine squared A minus 1. So there are three identities for the cosine double angle. We have cosine squared A minus sine squared A, 1 minus sine squared 1 minus 2 sine squared A, and 2 cosine squared A minus 1. That is all cosine double angle identities. For the tangent double angle identities, we make use of the tangent sum. Tangent of A plus B from our previous lesson is just tangent A plus tangent B over 1 minus tangent A times tangent B. Okay? If we let A be equal to B, we can have tangent A plus A. Just substitute b here with another a. We can have tangent a plus tangent a all over 1 minus tangent a tangent a. Simplifying that one, we can get tangent to a. Tangent a plus tangent a is just 2 tangent a all over 1 minus tangent squared a. So again, we now derive the sine double angle, cosine double angle, and tangent double angle identities. And we will make use of this in solving problems involving trigonometric identities, especially with double angle. Now, we will make use of the double angle identities for sine, cosine, and tangent in solving these two problems. This is finding the exact values for the sine 2t, cosine 2t, and tangent 2t. That is for sine, cosine, and tangent double angles. Okay, for the first problem, we're given sine t, where t is the angle, equal to 3 over 5, and t lies from pi over 2 to pi, or between pi over 2 and pi. And we're asked to find the values for sine 2t, cosine 2t, and tangent 2t. So, recall our double angle identities. We have sine 2t, that is just 2 sine t cosine t. Now we have values for sine t, but we don't have value for our cosine t. So we make use first of our fundamental identity. First, find a value for cosine t. From our fundamental identity, we have sine squared t plus cosine squared t is just equal to 1. This is just, our sine t is just 3 over 5 squared plus cosine squared t equals 1. So this is just 9 over 25 plus cosine squared t equals 1. Subtracting 9 over 25 both sides, we get 1 minus 9 over 25 on the right hand side. So we have cosine squared t equals 1 minus 9 over 25, or simply this is just 16 over 25. Getting the square root of both sides, we have cosine t is equal to positive negative 4 over 5. But take note, our t is on the second quadrant. This range here is on the second quadrant. So our cosine in the second quadrant is negative. So we will use the negative 4 over 5 for our cosine t. So now we have the values of our cosine t. Again, we have sine t equal to 3 over 5 and cosine t equal to negative 4 over 5. We can now solve for our sine 2t as well as our cosine 2t and our tangent 2t. So sine 2t, or double angle identity for sine, we have 2, our sine t is 3 over 5, and our cosine t is negative 4 over 5. Simplifying this one, we have this over 25. 2 times 3 is 6, times 4 is 24. And we have a negative sign. So the exact value for sine 2t is 24 over 25. Now for cosine 2t, okay, we just make use of any of the three identities. So we make use of the first identity, cosine squared, okay, cosine squared t minus sine squared t. Again, we have the value for cosine t, negative 4 over 5 squared, minus 3 over 5, the value for sine t raised to the power of 2. So 4 over 5, 4 over 5 squared, that is 16 over 25. We have a positive 1 since it is raised to the power of 2. Minus 3 over 5 squared, that is 9 over 25. Simplifying that one, we have the value for our cosine 2t as 7 over 25. Now for our tangent 2t, let me just erase this one. Tangent 2t, we have 2 tangent t over 1 minus tangent squared t. Okay? To make use of the identity for tangent, we can write tangent as sine t over cosine t. Here, we can write this as sine squared t over cosine squared of t. So, it gets a bit complicated, but we can manage. Alright. 2. Okay, we have a 2 here. Sine t is just 3 over 5 divided by negative 4 over 5. And the denominator, we have 1 minus sine squared t. Again, 3 over 5 squared. All over 4 over 5, or negative 4 over 5 squared. Simplifying this one, we get okay, 2 times, this is just equal to negative, this is just negative 3 over 4. Okay? And for the denominator, we have 3 over 5 squared, this is just 9 over 25. Let me write this one, 9 over 25. Times 4 over 5 squared, that is just 16 over 25, or we can have the reciprocal directly. This is just 25 over 16, since we have a division here. So this is negative, in the numerator we have negative 6 over 4. In the denominator we have 1 minus 9 over 16. Let me just erase this one. It's a lengthy explanation. Okay, swallow the arrow. We have negative 6 over 4. Simplifying the denominator, we have 16 minus 9, or negative 6 over 4 divided by 7 over 16. Okay? When dividing fractions, we get the reciprocal of the denominator and proceed to multiplication. 16 over 7 is the reciprocal of 7 over 16. And we go to multiplication. 6 times 16, we have 96, or negative 96. Or simply, we can just cancel out. Cancel out 4 here. So 6 times 4 is just 4. This becomes 1. Negative 24 over 7. So our value for tangent 2t, tangent 2t, the exact value for that is negative 24 over 7. Okay? We'll go to another problem. Let me just erase this one. For the second problem, we're asked to solve for sine 2 theta, cosine 2 theta, and tangent 2 theta, given the theta is an angle in the first quadrant and sine theta is equal to 1/3. Okay. So we have sine theta equal to 1/3. So we need a value for cosine theta in order to use the double angle identities for sine, cosine, and tangent. So from the fundamental identity, we have sine squared theta plus cosine squared theta is equal to 1. So sine squared theta is just 1/3 squared plus cosine squared theta equal to 1. Simplifying this one, we got 1/9 plus cosine squared theta equals 1. We subtract 1/9 or 1/9 of on both sides. We can get cosine squared theta is equal to 1 minus 1/9. Finally, cosine squared theta is just equal to 8/9, and cosine theta is just the square root of, positive and negative square root of 8/9, or simply that is cosine theta. Since our theta is in the first quadrant, we have the positive value of our cosine. So we have 2 square root of 2/3. This is positive. So again, we have the values for our sine theta and cosine theta. So we can now solve for our sine 2t, or sine 2 theta, cosine 2 theta, and our tangent 2 theta. Again, our sine 2 theta is just 2 sine theta cosine theta. We have the values for our sine theta. Sine theta is 1/3. So we have 1/3 here. Times cosine theta, 2 square root of 2/3. Simplifying this one, we have 4 square root of 2/9. Again, 2 times 2 is 4, square root of 2, 3 times 2 is 9. So we have sine 2 theta. Sine 2 theta is just equal to 4 square root of 2/9. For cosine 2 theta, cosine 2 theta is just cosine squared theta minus sine squared theta. Cosine squared theta, we have 2 square root of 2/3 squared, minus sine squared theta is just 1/3 squared. So these are the values of our sine theta and cosine theta we have solved a while ago. So 2 square root of 2/3 squared is just 4 times 2/9 minus 1/9. This is just 8/9 minus 1/9. We simplify this, we get 7/9. The values for our cosine 2 theta. For the tangent to theta, okay, let me write this tangent to theta in this part. So we have cosine theta again as 2 square root of 2/3. So our tangent to theta is equal to 2 tangent theta, or simply you can write that as sine theta over cosine theta. This is tangent. And for the denominator, we have 1 minus tangent squared theta, or sine squared theta over cosine squared theta. Right. Substitute the values for sine and cosine theta. We have 2 times sine theta is just 1/3. We multiply it with the reciprocal of cosine theta, that is 3 over 2 square root of 2. Since we have a division in this part here. For the denominator, we have 1 minus, again, sine squared theta is just 1/3 squared. We multiply it by the reciprocal of our denominator. We have 3 over 2 square root of 2 squared. So, further simplifying this one, we can get 2 times, this is 1 over 2 square root of 2. For the denominator, we have 1 minus, this is 1 over 4 times 2. Because this will cancel out. This is 9. And we have 9 here. That will cancel out. So, simplifying this one, we can get 1 over square root of 2. Oh, sorry. Square root of 2. 1 over square root of 2. For the denominator, we have 1 minus 1 over 8. So, this is just 1 over square root of 2 times 1 minus 1 over 8 is just equal to 7 over 8. 7 over 8, when we get its reciprocal, that is 8 over 7. To simplify this one, we can get, let me just erase this one. We can get, okay, just follow the arrow. We have 8 over 7 square root of 2. Rationalizing this one, we have 8 square root of 2 over 7 times 2, or 8 square root of 2 over, or that is rather 4 square root of 2 over 7. The value for our tangent to theta. So again, it is the use for tangent, sine double angle identities, cosine double angle identity, tangent to theta. So again, it is the use for tangent, sine double angle identities, cosine double angle identities, and tangent double angle identities. That's all for today. See you in my next edition of our tutorial. Thank you for watching, and God bless.